Sweet. Okay. So yeah, let's just go for it. Don't get too close to each other. But we don't have a big class here, so we're gonna do our heights here, and we're gonna make a box plot. We're gonna get our 5-number summary. We're gonna do IQR. What else is on this page that's super important? And then we're going to talk about if we have any outliers. Okay, so what I want you to do is socially distance without, touching each other or coughing all over each other. Let's say the shortest person comes stand over here by the stool, and then we're going to zag around over there, and then if we have to, come over here. So I know I'm one of the taller people, so I'm going to come stand over here. So let's get our height from shortest to tallest. Get you out of your chairs and moving.
Let's go. See, you're the outlier. I'm not the outlier.
If you would have asked me in 5th grade, I would have
Right,
been like,
let's
but not
see.
anymore.
Yeah, I think
I think I shrunk since 5th grade.
I'm 5'2".
I was 5'8" in 7th grade.
Yeah, this one.
And I was tall.
Yeah, that looks pretty
Yeah,
good.
I'll be wrong.
That looks pretty good where y'all are at.
Yeah, so
You think? Okay. I think it was close.
I'm over here.
His hair.
Yeah, it's like the hair that.
Yeah, counting the hair.
I don't know. Okay. All right. Sweet. So, what did I need to do? I needed to maybe get these heights first. Why can't I go sideways? There we go. Okay. So let's get our heights on here. So we got to convert it to inches though. So inches. So roughly, what's your height, Alyssa? 48. Okay. So that's 48 plus 8, 56. Y'all check my math. Is that right?
Yeah.
Okay.
Right.
All right. Okay. Oh no, I gotta do this again. Y'all are pretty similar. Okay, so that's 60 plus 2. That's 62. 62. All right, so we got 2 at 62. Probably about 5'3", you'd think?
Sure.
Yeah. Okay.
I looked it up as 65.
Okay. These are just y'all are probably all about that. Same height there. Okay. All right. Julie. Okay.
68.
Okay. 70.
You have 71.
Maybe 71, and then maybe I'm 73. I don't know. What's 73? 70.
Oh.
72 is 6 foot though, right?
Yeah.
Y'all are taller than 6 foot.
Are you sure? Because my doctor told I thought I was 6 foot, and my doctor told me no.
Cause I'm 6'2". I'm like 6'2", 6'3".
Where do I go?
Get in height. Where let's see. You're probably in front of Jada Lee. You think?
6'5". Totally.
Maybe.
Put her on 70. Yeah.
Yeah, I don't know. I think I'm gonna move. I think I'm gonna move these this way. I know I'm 6'2". Okay. All right. Sweet. So let's do. It's kind of nice to be interactive here with the median. Where's our median person? So I'm part of this. So where's our median? So one.
For this group of, yeah, for this
Yeah.
group of data.
Is it Aaron?
Yep.
Yeah.
Okay, Aaron. So you're a median. So let me kind of come over here. It's kind of hard. Okay, median. What were you again? What was your number that we?
65.
65. Okay. All right. How did we find it? We just crossed off all the middle. Okay. What about the Q1 and Q3? Did y'all? If you were in IB, did y'all talk about it?
Yeah.
What is the
It's
Q1?
Right?
It's like the middle of
It's like the middle of the.
Okay, yeah. So the Q1 is the quartile 1.
Yeah.
So quartiles are split into quarters. So what we do is we don't count Aaron, we don't count the median, and now we take y'all and get your median of y'all.
So between
Emma and
Emma.
We got an average.
Yeah, so what were y'all two? Were y'all the same number? Or
No.
no? What was it? Y'all were this?
Yeah.
So 62.5, right?
Yeah.
Okay. So 62.5 because it was in between 62 and 63. And then the same for us over here. What was ours? So y'all two
I was 68.
I ended up saying 68 and 71. So
So
what's
69.5.
yeah, 68 and 71 would be 69.5. Okay, and then let's just do our minimum. So minimum was 56, maximum was 74. So minimum 56, maximum 74. All right, y'all can take a seat again, just to get you a little active and see it in person. It's not really needed, but at least it gets you up. For the recording, no one touched each other, just so you know at home. Make sure to hit subscribe and like, comment for all my followers.
Can you go up to the dot plot?
Yeah, I'm gonna maybe put it back here anyway. Alright, so let's see. We had a 56. Does your notes have 2 dot plots or just one?
Yeah.
Okay, well, let's just do the, oh no, we want to do the box plot on this.
plot.
Okay, never mind. Yeah, y'all put the dot plot on there. The bottom one is our box plot. So, make the dot plot up top. Trace it. So, right, the median, since we had an odd number of people, the median was an exact person. It was Aaron. But if it was even number, we'd have to do the average, just like we did for the Q1 and the Q3. The thing I want to point out is if you did do that, when we did our Q1 and Q3 calculations, we didn't count the median. But if the median was an average, like let's say we had like a 64 and a 66 person, those people would then be counted into that Q1 and counted into that Q3. But like Erin at 65, we didn't count her on either side. But if we had to do an average of it, she would be, her number, or the 2 people that got average would still be counted. So do y'all need me to go back to the dot plot? A few more seconds. Okay. So make a note or whatever. So the Q1 equals the median of first half. And so it's called a quartile 1. And so quartile is force, so it's basically that the median is that exactly halfway number, not the average, but it's the halfway of all of our numbers in order, and so the Q1 is basically that same thing.
Like
So
quarter one.
it's almost like the 25 percentile. We're going to talk about percentiles. Next, it is the 25th percentile. The median is the 50th percentile. So the Q1 is, or the Q3, I'm sorry, is that 3/4 person. So the 3rd quartile. So the median of the second half of data. Yeah.
So when you're calculating those, you don't actually count the median, like that doesn't.
If the median was a number. If it wasn't a number, if we had to get the average of 2 people, then you would count those 2 people in those other numbers. But since this was Erin, we did not count her. Yeah. Also, for the most part, you can plug into like Stapplet or your calculator to find these too. So, all right. So these all together are called the 5-number summary.
I'll write this on number 4.
Yeah, you can write that. That's what those are. I just ran out of room for myself. If you did too, somewhere point to yourself that these right here are your 5-number summary. You have 5 numbers, and what the 5-number summary tries to do is give us a quick snapshot snapshot of our data. So I have my minimum, my maximum, all my quarters, and I can kind of quickly see like, oh, okay, I get a feel of where my middles are and where's a group of data and stuff. We also use the 5-number summary to do a box plot. So I'm going to put my minimum. I'm going to come over here and I'm going to start at my minimum. Maybe I'll just mark these first. So I'm just going to put a dot at each one real quick. So those are my 5 numbers. And it's some box and whiskers plot. So with that, the first quarter of your data is represented in a line up until the Q1. And then the next quarter of the data is boxed in until the median. And then you have a third quarter of your data is boxed in to the Q3. And then finally, the fourth quarter of it is a line stretching out to the max. And that's your box plot. So it's 5 numbers to make it into 4 quarters of data. Got 1, 2, 3, 4 quarters there. And that's kind of telling me, it's showing me, it's another way, this is another quantitative graph. So there's advantages and disadvantages. Like a disadvantage is, I can't really tell, where my numbers are in this grouping on the bottom. Like, we know from our dot plot, but if all I was given was this, I don't know if I have a bunch of numbers over here at 61, and then 1 number over at 56, or if I have like 4 numbers over here at 58 to 56, and then also the same thing over here. I don't know if I have like all these data points over here, or if they're spread. So it's it has useful things like being able to quickly see where the median is and comparing between groups, but also it has its downfalls. So yeah, we've got our minimum, Q1, median, Q3, max. Sometimes the median is just referred to as Q2 because it's the second quartile. Let me see. Okay, yeah, so we are doing the IQR. So the interquartile range is the Q3 minus Q1. And so it is a range. So just like what we talked about for range, it's not the interval, it's the actual number. And I guarantee you, like an A, B, C, D, E answer choice, if they did this, one of the answer choices is going to be, the interval, and the other answer choice is going to be the number. So make sure to choose the range as the number, not the interval. So like on ours, it would be like 69.5 to 62.5, right? Yeah. So answer choice A is that. No, that's the exact numbers you just did. But our actual interquartile range is a range of 7. So that's just saying the interquartile range is the box on the box plot. And the box on the box plot is the middle 50% of my data, because it split it, like here's 25% of my data, here's 25% of my data. It splits it into quarters, and so the IQR tells me 50% of my data is like right there in the middle. And going back to that last lesson, we said that IQR is resistant, because if I put an outlier way out here, the IQR is really not going to shift that much. That middle 50% is still there. Okay, so IQR, it's a range, not a number. And then the way we're going to calculate outliers, so how do I know how far away, like am I an outlier at 74? Was Alyssa an outlier at 56? Well, there's an actual, outliers are kind of up for interpretation, but there is kind of one agreed upon way you can do it, which they do in statistics. It is, we want to see if we're too small or too big. And the way we do it is from the quartiles. We do it from Q1, and we do it, are you way too big, from Q3. So what happens is, we take our IQR, we take the range of our middle 50% of our data, and we multiply it by 1.5, and then we say if you are that far above or below, so if we are too far that way above or too far below that box range, then you are far away. Basically, if they give you the box and then some, 1.5 of the box to be away from it. So if I was to get this one, our IQR was 7. So 14. I think that's like 10.5 maybe. Should double check it. Okay. So 1.5 IQR is 10.5. Where did they get 1.5? It's just been agreed upon to be like, okay, that's a reasonable number. Outliers are kind of vague and up for interpretation, but this is something that is agreed upon. So I take my IQR, I multiply it by 1.5, and if I am 10.5, so if I come back to my box plot, so I go from Q1, and I'm going to go, if I am 10.5 less than that, or if I am 10.5 above this other part of the box, which is Q3. So let's see. I'm going to do, let's go for this too small. So our Q1 was 62.5, and I'm giving myself 10.5 to be smaller than. So that's 52. So anyone who is 52 or no, I guess less than 52, so like technically 51 or less, you would be considered an outlier. So we don't have an outlier too small. And then, what was our top one? 69.5 plus 10.5. So that's 80. Okay, so we don't have any 6'8" people in here, so unfortunately. So if you were 80 or above, that is way too big compared to just our class data set, not necessarily the population, just the people that we had in here. So we didn't have anyone way out here at 80, we didn't have anyone down here at 51 or whatever, and so our box plot just stays like it is. If we did have an outlier, like let's say I did have a person over here at 81, it would be represented by a dot. So if I have an outlier, I don't continue my line all the way out to my biggest point. I put a dot for an outlier. So that is kind of important. So if that person is an outlier, and let's say we had him graphed all the way, out there. If I find that 81 guy is an outlier, and the next biggest person was me at 74, what I'm going to do is I erase that line all the way to the next person, which was 74, and then that person just gets a dot left out there. So if you see a dot on a graph, or sometimes it's like a star, that's an outlier. But he's still the max. This guy at 81 would be our max height person. We just don't draw a line all the way out to him. Because then that shows like, here's most of our tall people over here, and then we do have this one guy that's like gonna go to the NBA or something. All right. So box plots, IQRs, 5-number summary, and maybe the more important thing, the outliers. That might not be as familiar to you, but calculating an outlier. Okay, I had done this split of males and females, but I have that in the check your understanding, so I didn't have that in my own notes for the year, so I must have thought I needed to take that out for this year. So we're going to do that. The check your understanding has 3 different box plots that we're going to be comparing, so we'll just deal with that then. So I guess some big ideas that I did. So you got your 5-number summary. You make your notes whatever. If you already feel comfortable looking up where we already talked about them, then it's fine. So you got your minimum, Q1, your median, your Q3, and your max. And it's just a way to represent our quantitative data. Maybe make a note, the median of the first half, and the Q3 median of second half. Okay, other thing, outliers. So I take my middle 50% of my data, which is my IQR. So I take that, whatever that range is in the middle of my data. So if it's really tight in the middle, then there's more room for outliers. And then we gave some wiggle room of not just an IQR, but 1.5 of those. So we get that number. And then we're going to check, is it way too small or way too big? So if we're looking for a small outlier, it would be the Q1 minus 1.5 IQR. And if we're looking for a big outlier, I go to the biggest side of my box, Q3, and I add whatever that number is, that range. So if it is above or below those things, it is either a small or a large outlier. All right. Sweet. Yes. Yeah. Okay. So let's do the check your understanding. Maybe I'll give you 3, 4, 5 minutes here. This is our last thing we're going to do, then we're going to be done. So we got some time. And so we've got these box plots of total income for 40 random households from each of these states. Compare the distributions of annual incomes in the 3 states.
What does that mean? Like, just put immediately.
So yeah, so this is going back to Friday, where anytime I'm asked to compare the distributions or interpret the distributions, I need to do SOC V plus context. So you can even bullet point each of those things, or you can just write a paragraph. But tell me, compare. If some of the shapes are similar, then say that they're similar. If they're different, tell me how the centers line up and the variability lines up. Are some bigger, some smaller? All that. So go through each one. And
How can we tell shape from the box?
What's that?
How can we tell shape from the box?
Yeah, so shape is tougher to do, but like let's go for Massachusetts here. What do we think Massachusetts probably is looking like? Like there's definitely there's definitely a tail here where there's not, like these are more spread out for sure. The thing is, it's hard to tell. We don't know where all of these data points are in here. They might be all right here. They might be there, but at least we know that they're like right there. And then same for these. We know that there's a lot stacked up here. So I can guarantee on Massachusetts that it's a lot here and then it kind of starts spreading. But like on Maine, like it's kind of spread. There's a big grouping. It's a little spread, there's a number. I mean, this is probably I would probably even say roughly symmetric for Maine and Connecticut.
Okay.
Yeah. So that's kind of a downfall on the box plots, but yeah, if you have a really big tail on the box plot, you've got some
Does the
skew
star,
there.
like the little star, does that mean it's like an outlier out there?
Yeah, yep, if there's a dot, sometimes it's a dot, sometimes it's a star, and that's an outlier, yep.
How would we write that? Just like yes at Goodwood?
I just
Yeah,
wrote
so for the
outlier.
outlier section, you could say, Maine and Massachusetts both have outliers at blank and blank, while Connecticut has no outliers, something like that. Okay, so just give yourself, how would you do each of those? It's good to get some practice and writing it down practice. This goes for homework 1.2 and 1.3 as well. Anytime it's saying interpret or compare distributions, you're doing this little acronym, and you will get full credit for, that's a full and complete answer.
Once you do the context ones, you don't have to do it for like every sentence.
Yeah, so you can even do it originally, like the shape of Maine's 40 randomly chosen households' average income is symmetric, and then you don't have to say it ever
Okay,
again.
cool.
While Massachusetts was skewed right, while Connecticut's was symmetric, and then don't
Oh, were these
mention
supposed to
it.
be sentences? I was
Um,
just breaking them up like.
You only have to do
Yeah.
one sentence.
Yeah, like
I
for the
can- I can
centers and the
actually, yeah.
spreads, you don't necessarily have to, but
I
like
can just
for
go
the,
through and do it.
yeah. But like you at least want to, like when we're comparing here, we want to like point out differences and like we want to between these are
Mm,
and these
versus
are
the-
different, and then these both have a high, well, this one doesn't, and like these two could be simply more connected as well. Yeah. So definitely use comparing smaller than, greater than. Large number of teachers out today.
Uh-oh. I bet teachers are like, positive.
Yeah.
As long as you wear a mask and do that. You think they're all sick, or do you think they're all just like nervous?
Oh, the V, do you want us to do like all of the like the range and all that kind of?
So yeah, on this for the V, just on especially on a box plot, just use IQR. Yeah. So like the IQRs, how do they compare to each other?
She's been there forever, but I was just like, I'm gonna retire, and then it's not showing. Yeah, she's like, technically, I guess it's like increasing the sort of I guess like.
How would we, where are the centers?
Talk about centers.
Yeah.
So
You can't get the mean.
I would talk about the medians in this case.
Okay.
On box plots, you don't have an option to really talk about the
Yeah.
medians. Yeah, just talk about how the
Because this one's
medians.
skewed right.
Yeah.
Usually we need means that.
No, on skewed you'd want to use the median. On symmetric you can use the mean.
Did I read that wrong? They don't have to in like her school.
Yeah, I think you
Like,
should.
one, and they're only
Oh,
like,
yeah.
That was like
Yeah,
the
but it's
Yeah.
okay, like on symmetric data, to still use the median.
Okay.
So on a box plot, we just always use median.
Okay.
Like the little
Yeah.
kids don't really.
And on variability, just use IQR, because it's given to you. Or you can talk about range, but
You said it's
there's
nice.
IQR, you can do either one.
Okay. Friday?
But yeah. Alright, so I'm just gonna kind of say out what I wrote instead of writing it maybe. So I'm gonna say, so like for mine on this one, an example, so just going through each thing. So the shape of the distribution of income for Connecticut and Maine, you could probably make a case for Maine with an outlier that it might be slightly skewed right, but it's really tough to tell on this one. But I would say the shape of distribution of income. So as soon as I said that, I got a check for context. So maybe I'll go through that. So I talked about the distribution of income. In Connecticut and Maine are both roughly symmetric, while Massachusetts has more of a skewed right distribution. The center, or I'll talk about outliers. Maine and Massachusetts both have an outlier at roughly, 160 and 425, while Connecticut does not have an outlier. The Massachusetts has the highest center with a median of roughly, 90 or 100, while Connecticut and Maine are smaller. You can list those medians if you want. So for center on box plot, it already gives us the median, so we're going to use those. And then the variability is largest with Massachusetts, and you can either talk about the range or the IQR. So both of them for Massachusetts was biggest, while Connecticut and Maine are roughly similar variabilities, stuff like that. So I'm listing, are they similar, are they different, which one's the biggest, largest, some they're same. So if you're just going through, that can be in bullet points, that can be in sentence structure, either way, but you do need to have comparative language, not just list what they are, but list them and then say, well, this one's bigger, this one's smaller. If it was just one, like if we were only doing Maine, then you can kind of list it out. But if you're comparing, you got to make sure to say greater than less than. Okay, so that's what we got. You got quantitative data, standard deviations, IQRs, mean, medians, ranges, box plots, resistant and non-resistant measures, outliers, all that good stuff. So let's see, going back to standard deviation again. Standard deviation is average distance from the mean. So we typically vary blank from the mean, like 6 dogs from the mean of 8, whatever. Okay, so that's that. You got homework due on Friday, a quiz on Friday, test 1 week from today. All right.